Oh my goodness, this just looks like a mess. Like, look at this. Look at this, like, wall of code. Wow. Here's something I haven't seen before either. Hey, what's up, guys? My name is Cherno. Welcome back to my code review series, a series where you guys send me a code and I take a look at it. Today, finally, I think, at least it feels like that, we are looking at an actual small project, because last time we looked at like this whole Vulkan engine thing, which was great, don't get me wrong, but I feel overwhelmed sometimes looking at so much code and trying to fit it into such a small video. So just because it's like December and the holiday period is kind of upon us, let's relax, let's take a look at a smaller project, hopefully a good, high quality small project, which should hopefully prove to be a good example for beginners in programming or just people new to C++. Should. Because I haven't actually looked at the code. I took a brief look at the project. It looked pretty good on paper, but we're gonna dive deeper into it and have a look at whether or not it lives up to the status that I seem to have assigned it. And actually, before we dive in, what do you guys prefer? Would you like me to spend more time making longer videos, deeper diving into more complex projects? Or do you find there's a lot to take away from small projects as well? What do you prefer? Let me know in the comment section below. Hey Cherno, my name is Daniel and I have a bachelor's degree in computer science, right? So this guy should know what he's doing. I really appreciate videos and learn a lot from them. I'm sharing a C++ Snake project I made. I would love to hear your feedback. It's my first game. So how do you have a bachelor's degree in computer science, but this is your first game? I mean, I don't know where you're from, but back when I learned programming, like games were pretty much the primary focus of what we were taught, just because, well, I mean, I think games are a really good thing to teach people who are programming because of numerous reasons. Maybe I'll discuss that in another video. Games kind of just encompass a whole range of different skills that you need to learn for programming. But anyway, I'm curious how this is your first game if you have an entire degree in computer science, but we'll check it out. So here's the repository. I'll have this linked in the description below. Simple classic Snake game implementation using the raylib library, which is great. I used raylib recently for the first time to remake my first game that I ever made. I'll have that video linked up there. Really good library. I really like it. So it'll be interesting to take a look at another project here that was made with it. So it's a pretty standard process here. We can, build the game and then start. I mean, it's Snake, right? So I expect this to be pretty standard gameplay. Now, those of you looking to improve your skills in computer science and math, I highly recommend you take a look at the sponsor of this video, Brilliant.org, because they have a 30-day free trial that you can use to check out their entire platform. So Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. As I mentioned, I think they're a really good place to learn the beginnings of computer science because first of all, their courses are really bite-sized. And I think in the beginning when you're learning computer science, it can feel a bit overwhelming, but as long as you just work at it consistently, you'll continue to make progress. The fact that the courses are visual and interactive as well, and they quiz you to make sure that you're learning, means that Brilliant.org is honestly one of the best places on the internet to learn this kind of stuff. It also eases you into real programming languages such as Python, where you can learn about AI, which I think is pretty cool. But honestly, where would computer science be without math? And Brilliant also has lots of really good math courses, ranging all the way from beginner level stuff to things like calculus, which I especially think benefits from Brilliant's way of teaching, being visual, engaging, interactive. It's just such a great way to effectively learn all of these difficult topics. And as I mentioned, they currently have a 30-day free trial that you could use to check out their entire platform. Just go to brilliant.org/thecherno, link will be in the description below. It's the holiday season at the moment. It's the perfect time to finally sit down and learn something. And that link will also get you 20% off an annual premium subscription. Huge thank you to Brilliant.org, as always, for sponsoring this video. Okay, so this is what the repository looks like checked out. Let's have a quick look at the way that this is all laid out. So the one thing that I perhaps don't like is the presence of this main.cpp file just in the root of the repository. It doesn't really make much sense, especially if you look at the actual project and you see that main belongs to this Snake game, which is an executable. But then there's also a Snake static library, which has the actual Snake game, I presume. And then we have raylib over here as well. So it's a little bit of an odd choice to leave main out here. What I like to generally do is every module that I have in my, Visual Studio solution in this case, I would make sure that that's actually in a separate folder. So this is great, the fact that Snake is, in its own directory with all of these files in it, presumably. But I would also make a directory for Snake game, put main in there, keep things a little bit more organized. Now, raylib, I imagine, is going to be in this third folder. Usually we call this something like third party or vendor, something like that. Third, I've never really seen it written this way before. It's kind of funny. It's got a CMake list over here, and then we have raylib. Now, this was, I believe, a Git submodule, which is fine. Now, if the audio sounded weird up until this point, I apologize. I've forgot to hit record on my sound recorder. So my little backup microphone was saving the day, luckily. Anyway, what I was saying was in the remake of my first game where I used Raylib, they have a CMake file that actually downloads Raylib for you. So you don't actually even need to submodule it. I'm honestly not sure what a better solution would be. What do you guys think? Would you rather have a CMake file that just fetches the dependency for you, or would you have Raylib as a Git submodule? Let me know. But that's where Raylib is. I made a build directory and I ran CMake, which generated the snake solution file and all of the project files. And then we have the actual game stored away over here with the resources, the source code. We've got a folder called include for all the HPP files. And then over here, we just have things like a README, Clang format, Clang tidy, that kind of stuff. So I can't really fault this project layout, I guess, too much. The only thing is, yeah, the main file would be nice to have inside a directory, but this looks really good, really clean. So I think it's a pretty good example for those of you who might not know how to set up your C++ projects, you know, using CMake. Okay, so let's get into the actual game, I guess. Let's hit F5, build it, and run it. So here we go. Lots of logging and stuff coming from the console. I think this is all just from Raylib. So let's hit a button and we're off. We're playing Snake. I remember playing this on like my dad's Nokia phone when I was like 8 probably. So that was back in what, like 2002? The rest of the video is just going to be this, by the way. So you might as well skip to the end. All right, cool. So I guess we should lose. Let me collide with my own tail. Hey, okay, cool. All right, that's Snake. Would have been nice to see like a main menu or something, potentially. Maybe like it stores your high score like in a file. I don't know, that might have been cool, but otherwise, looks like a pretty simple game. So let's have a look at if the code is simple as well. Okay, the first thing that I want to say that already makes this less simple for some reason is the fact that we have like these two modules, right? So Snake game and Snake. This is a static library. This is an executable. Why? Why separate this out? Doesn't really make much sense to me. Like, first of all, they're both being compiled into the one executable file, obviously, because this is a static library. But also, we generally make static libraries as separate modules that we may want to reuse, potentially. This is obviously not a scenario in which that would happen. So like a good example, well, this is more complicated, but like Hazel, you know, Hazel's core library, like the meat of Hazel is a static library, but then we have multiple executables that will use that core module, right? So like the editor will use it, the runtime will use it. A launcher might, for example, use it as well if it needs lots of features. Hazel's multiplayer server will also use that core Hazel module. But here, I don't think anything is going to use Snake except for Snake game. So this already introduces like this extra layer of complexity, especially because there's nothing in Snake game, but this is just a main function and like 2 lines of code. That doesn't make too much sense to me. I would just put main like into here and then just have Snake be an executable that links Raylib statically. But other than that, if we have a look at the code itself, the code looks great. I love seeing really simple main functions where we just have this game and then we call game.run and then we actually, I'm assuming we use some form of like, we use RAII here to initialize everything we need in the game's constructor, and then the destructor is going to destroy all of that, right? Which is something I like doing. I know a lot of people don't like that because they want explicit like game.init and game.shutdown, for example. Some people like to be a little bit more explicit with it. I think for a simple example like this, it's totally fine. So if we go to game, let's have a look at this. Game, okay, games are drawable. Oh, and also I would definitely indent this, right? So that we're not on the same level as this namespace. And then again, I would, you know, also do this. So any formatting advice I'm giving, just like that's obviously very subjective. So game is a drawable. Okay, so we've got this like hierarchy going on. So I'm gonna definitely take a look at that because I feel like that's adding some complexity where it's not really quite necessary unless it's a Raylib thing, but it doesn't look like it. So we'll explore that. But otherwise, here's the constructor and destructor. Destructor I'd probably mark as virtual. I mean, we have it marked virtual over here. So obviously that means that this is gonna be virtual as well, but I like to be a little bit more explicit with things like virtual. Again, same for all of these functions, right? Well, not all of them, but like this draw function is an overridden function, right? So I would also mark this as virtual. Again, completely unnecessary, but in my opinion, it just makes the code look a little bit more readable, a little bit more clear. Okay, so let me just revert that stuff. So the game constructor, obviously you can see does all the initialization, the destructor does all of the destruction. So that's kind of cool, I think. And obviously for something like game, where the scope of this object is your entire application, I think it's totally fine to set it up this way. So let's have a look at some of the initialization stuff that happens. So we have mostly Raylib initialization stuff. We do init window, set target FPS, init audio device. And then we have this interesting like if, you know, MSC version. I don't really like the way that this is written. I'll explain in a minute, but basically, you know, this is kind of checking to see, are we compiling with like the Microsoft like Visual Studio or Visual C compiler, right? So MSVC is a compiler, they compile C++ code. If we're using it, we do this for some reason. Otherwise, we do this. So why are we doing that? The answer is pretty much always strings. And you can see in this case, what's actually happening is so specs and then snake eat sound is I'm expecting, yeah, a file system path, which is great. And we'll talk about that more in a minute. But basically, this is a file system path. However, this load sound function, you can see it needs a const char. It doesn't need a W char, which is a wide character, like string in this case, because it would be a pointer. It wants a char, which is a 1 byte, per character data type. However, if you just do specs snakeeatsound.cstring, what you'll get is, well, I was hoping it would just tell me, but of course it's saying std file system path value type, right? So we have to go in here and we have to look at what value type is. And so if we jump to value type, you can see it's a W char T, right? So it's 2 bytes per character. In fact, we can kind of jump to the definition. I don't know if this is like a built-in type, probably is in this case, but you can see that in most definitions, it's just defined as an unsigned short, which is 16 bits. So what we have to do is we can't just call .cstring directly. We have to actually get this as a string, which would give us an std string, which is like a UTF-8 string, and it does have chars as the underlying data type, and then we can call .cstring like this. But the issue with this code and why you can't write it this way, and you can see it's separated into 2 lines of code for each thing. Would have been nice, I guess, to group it like this as well. So we get the path as a string, we store it in an actual L value, we store it in a variable, and then we get the C string out, is because if you write the code like this, the issue is that what you're doing is the .string function returns an std string like by value. It's not like it gives you like a const reference to a string that is stored within this actual file system path object. And so it's creating a new string for you over here, which you're then calling .cstring on, which just gives you a pointer to the underlying memory, the data that is storing your actual string inside here. But on the next line of code, obviously, you haven't stored the actual string that's containing the buffer that is your pointer anywhere. And so it's gonna get destroyed, like it's gone, that's it. But obviously your pointer that you're storing still remains. And so if you try and then pass it into like a load sound, which can obviously all happen on one line, then you're gonna be pointing to memory that's been freed already. And so we need to actually store it somewhere long enough for this load sound function to actually read from that buffer to see the characters that make up our path, which is obviously mildly annoying, but necessary. However, it's not necessary, it seems. I wasn't actually 100% aware of this, but I guess it makes sense because Windows just loves its like wide chars. That most likely on a different compiler, and potentially not on Windows, you can just do .cstring directly, because instead of a W char, that would just give you a char pointer. So that's what's happening over here. Now, whether or not this is necessary to do, look, I would probably just do it like this, because this is going to work both ways regardless, right? I guess you could consider this a little bit of an optimization, but again, it's an optimization that happens in the init function, and it makes the code look way worse because you have these 2 like compile time branches basically. The other thing is, so using if and then MSC ver is a little bit of a weird thing to do, I think. I think this should be something like an if def instead. The reason why is because MSC ver is set to something. So in here, it's set to 1941. This is basically checking to see if it's true, right? So if it's not 0. So MSC ver could actually be set to 0, for example, here, and this branch wouldn't run. Whereas if you had an if def, it would, because it's just checking for the presence of this in the first place, not the value. So I don't know why this makes me kind of uneasy, because your MSC like version is not going to be 0 anyway. So obviously it's going to work in both cases. But I think this almost communicates the point of we're not just checking for a specific version, we're checking to see if this define exists at all, because obviously it would only exist if you're using MSVC. All right, and then we load stuff. So obviously no asset manager, no like complex code. I really like it when I can look at something as simple as this. And it also seems like the actual data that I guess stores the paths of the files we're trying to load here is also just stored somewhat statically inside this specs.hpp. And then we have a whole bunch of like mostly constant expressions, which is kind of cool to see, right? And then we have like these static const variables here. All right, so that's one thing I would immediately change. These shouldn't be static. Instead, you should make them inline. So you can't, first of all, just leave them as this, because there's going to be a version of this in every single file. These are const expers, so they get a little bit of some special treatment here. But if you did something like this, every file that we include specs.hpp onto is going to have its own version of this, because this isn't in a class, right? If this was like static inside a class, then there would only be like one instance of all of these variables essentially, and you wouldn't get any like multiply defined symbols linking errors. However, because this stuff, let me just indent this because I'm going crazy. Uh, but because this stuff is just in like a namespace and it's basically global variables here, you have to make sure that you're not defining more than one of them, right? So the issue with static is that static just means that every file that these are going to be included into is going to have its own version of that symbol. So you don't really want like these copied and duplicated across your binary. You want these to just be like one singular instance. And so to do that, if it's in a header file like this, you can just mark it as inline instead of static. And that will just make sure that you have one version of this. So this is probably what you were trying to do. And I would say this is like the correct way to do this. I also don't know exactly how I feel about just having these free floating. I don't know. I think like the way I would probably do this is I'd probably have like some kind of struct. I don't even know what I would call this because I don't want to call it like globals or something weird, but you could call this, I don't know, like game data, for example, and then you could have these things within there, and then you could refer to game data like, you know, some kind of like G game data, and then you'd have to make sure that's also like an inline instance as well. To me, I think that's just a little bit cleaner, a little bit more organized than just having these global variables, even though they are in a namespace. So obviously like it does feel a little bit more tidy than if they were just floating around anywhere. I still think having it in like an actual struct where obviously they're definitely going to be in a specific like layout in memory and everything, and you can have finer control over that might be just a better way to lay this all out. But yeah, like for such a small game, obviously, I think it's really good to have something like this, where you just cleanly have a header file that just defines all of your constants basically for the entire game. I think it's cool. It's nice and refreshing because it's just so simple, and I just love that stuff. Okay, so that's the initialization. The destruction just deletes everything we load. There's literally like only 3 sounds in this game. I think like, you know, this is where this is going to get a little bit subjective, but when we start dealing with things like, okay, well, we have a sound library basically, and that could potentially grow and we could have more sounds, we could have music or whatever. I think it becomes somewhat useful to start separating your code from all being in one place like this, just because you can have various systems like for different resources dealing with those resources. And if they are segregated and a little bit separated, then what it does is it keeps this file cleaner, because this file like is 150 lines of code. Obviously, it's not much at all, especially not compared to like the 5,000 line files that I'm totally okay with in Hazel. But you can start to see how there becomes a lot of noise in this code, right? Because like we've got unload sound, but we've got 3 lines taking up just unloading each individual sound. If we had more sounds, obviously we'd have something like this and it gets a little bit crazy. Now, obviously at that point, we could change the design very easily. Like for example, we could have a vector or like some kind of map of sounds, and then we could iterate through all of them, unload them that way. Or we could have, you know, some kind of audio or sound manager where we could just be like, okay, well, the sound manager, I'm just going to tell it to like shut down or something like that. And it internally would have all of your resources in a data structure, and it could, for example, iterate through them and unload them all one by one if you need to do it that way. But that's just something to think about, that like, yeah, it's definitely refreshing, I guess, and nice to look at code that is simple and just has everything in one place like this. But you also have to consider the fact that, okay, well, this is the game class. This is supposed to be like the core application, I guess, class that probably has like, you know, it's got all the draw and update functions. It's going to have the run function, which has the main application loop and everything. So is this all like our specific resources and going through them one by one? Is that noise that I could potentially, you know, outsource to like a different file? Okay, so initialization destruction we've taken a look at. So game.run is obviously the function that actually runs everything. So is running gets set to true. And then we have a lot of this pointer stuff, right? So this doesn't need to exist. I don't know why. I see people write this a lot these days, like in the code that gets sent to me. A little bit weird. I also wouldn't have 1-line if statements like this. Just drop it down a line like that. At the very least, it means you can like debug a little bit better, but it also makes stuff look a little bit better, I think, as well. So while window should close is false and is running is true, okay, we do update and draw. So why have a is running variable? I don't really quite understand that. So if you're going to check for this condition anyway and not ever set is running to, I guess is running might get set elsewhere to like false, and that would potentially make sense. I don't know. I think like in Hazel, for example, we have an is running variable that basically is sitting here and controls our entire application loop. But the difference is we're not checking for should the window close every iteration. We actually just get an event that's like a close event. And then if that's the case, we set is running to false, and that terminates the loop. So that's probably something else you could do. I don't know if Raylib is set up like that. I mean, Raylib uses GLFW, Hazel uses GLFW as well. And obviously there is like a window close event that you can get notified if the window, like the window close has been requested, and then you can handle it that way. So maybe that's something to consider. And then we have create snake and spawn new apple. So this, I guess, differs from initialization, which happens in the constructor here, because this is specifically initializing the game state. So again, this is why I think, one thing you could do is you could separate this into two different files where you have like a game file and a game class and then an application class, right? So these things like initializing the window, setting the target FPS, audio device, loading resources potentially, that might be game related. But anyway, you kind of have two different systems working here. You have the actual core application stuff and then gameplay related things. And having them all in one file, again, kind of just makes the two concerns very noisy because they're just intertwined in here, whereas they could easily be separated. So that's probably something I would do. I feel like in every second code review, I'm always saying, I would make an application class for this. So I don't know. If you guys want me to make some actual videos on just, obviously they're all subjective, but like how I would architect something like this, where it's like, okay, let's have an application class. Let's have this game class that has this. Let's have like a resource manager or something that contains this. Like, I'm not just going to end up building a game engine, you know me. But if you want to see something like that, let me know in the comment section below, because I feel like it'd probably be useful for me to be like, I would do it like this, and here's an actual example, or here's a video that steps through it, instead of just, getting you to visualize, I guess, what's in my head. Okay, so create snake, we'll just create the snake thing, which is a snake object. Utils generate random position. Okay, so what? What is this? Oh man, okay, so this is a bit of a mess. So snake has a constructor here, which has a default parameter as well, which is the initial head position. So that's where the actual snake starts in the game board. You can see it's not an explicit constructor, and so what that means is that we can just assign snake to utils generate random position, which of course returns a vector 2. So it's a little bit weird. We're relying on that implicit constructor basically to initialize the object. And I don't know, like I don't really like that, right? So I'd probably, be a little bit more explicit about the object that we're actually creating by like wrapping it in snake. The thing is, like, as I say this out loud, it's also like, but why would you do that? Like, you clearly don't need to do that. What are you going to do? You're going to go back to snake, and mark the constructor over here as explicit as well. Like, aren't you just making the code more complicated? I think so. Like, I don't know. Sometimes when I'm just used to doing things a particular way, and I'm like, okay, well, is this right? Like, doesn't this actually just look cleaner? And I guess it's okay. Especially when you have like snake over here, and the variable's called snake. So this isn't like snake position. So you're not going to get fooled into thinking most likely this is like just a vector 2. You'll be like, okay, this is the actual snake, I guess, and we're generating a random position for it at a particular area. So I don't know. Well, another thing, like, let me know in the comment section below. And then the next thing we do, I think, is spawn new apple, which, okay. So we got a little do while loop. So I kind of like this, because this is a brute force thing, interestingly. So basically what we're trying to do here is generate a random position. But of course, it could be that we put the snake, we do this create snake first, right? So the snake's been placed here, and there's obviously a rather finite amount of positions in this small game world. So what happens if the apple gets put here? Obviously that's bad, and we don't want that. So basically what we do in that case is we just try again. Like, okay, it happened to be exactly the snake position, so let's try again and, put our apple over here. Might sound dumb, but I honestly, like, what is the alternative? Like, you're gonna write a function that specifically excludes a given position or something? I don't know. You could obviously go crazy. And if the snake is here, then let's like cut up the game world into these like, 4 partitions or something. And then let's pass these bounds. Let's pick one random partition first and then pick an area within that. And that way we would never have to do. Anyway, that's obviously, that I think is over engineering. So this is, this is nice and simple. Obviously it's going to work really well. And in the first, like, it's a do while loop as well, because obviously this is going to be false, I think, like 95% of the time, right? So it's only ever going to run this function once, but possibly twice, once every 50 times you start the application. But yeah, that's kind of funny. Okay, then we have our main game loop where we update and draw. So the update is gonna, again, with the this and a one-line function. Bro, come on. I mean, is Clang format letting you do that, really? So let's have something like this. So if you want one line, whatever, you do you. Handle snake key press. So, okay, so get key pressed, and then this is a switch statement. How does this work exactly? I mean, I did make a game in Raylib, but I don't really remember how this works because, so I guess we kind of poll Raylib to get a key pressed, which just gives us an int. But what if there's multiple keys pressed? like within a frame? How does that work? Because we only check for one. So I'm actually interested in this function here. Get key press, call it multiple times for keys, queue returns 0 when the queue is empty. So yeah, I mean, I don't know. Maybe this is something that you want to process in like a while loop. The thing is, again, for such a simple game, it's almost like, well, you can't go up and then later change your mind and go right, potentially. Maybe you want to be a little bit more strict with key presses. So you only press the one key, and if people try to press multiple keys, you just kind of ignore the rest. Sure. I guess for like a game of this simplicity is probably fine. And then we just set this enum next snake direction, which is just like an enum class, which is cool. This reminds me of my kind of code style because I always write none usually as a state, and I set it explicitly equal to 0, even though you don't have to. It's kind of cute. It reminds me of my code. And then again with this, which definitely doesn't remind me of my code. So if should move snake. Okay, so should move snake is a little function here. Cool. We're using a namespace inside a function instead of in the file globally, which is great. I love to see that. We're getting a high resolution clock here, which might be, I don't know, a little bit overkill. Is high resolution than the nanosecond one? I'm not sure. Maybe not. I mean, we're getting it in milliseconds anyway, which is good. And so this is kind of like our timer. So we have a static variable here, which like, normally I'd probably be like, yeah, make this a member, right? Instead of just having like a static variable inside here. But on the other hand, it's like, it keeps it nice and like, it keeps it nice and internal to this function, which I think is nice. And so all this function is really doing is it's kind of just returning obviously true or false based on whether or not enough time has passed for us to move the snake, because the snake shouldn't move every frame. It has to move like a set amount of time. And that set amount of time is this snake move rate, which is 150 milliseconds. And it's nice to see this stored as a milliseconds variable already. So it's obviously easy for us to compare. And then we're returning true or false here, right? So we have to update the previous snake movement time to now, and then return either true or false. So that's pretty good. And then the function is even const. So there you go. What more do you want? So if you're thinking what I'm thinking, like obviously having this stuff inside handle snake key press is a little bit odd. Like I feel like this, like, should this just be a function obviously that processes keys and just does something with them? Maybe. I feel like potentially this should be like in update snake or something. You could even put this into the actual snake class itself, because obviously there is like a snake class. So maybe the snake could move itself as well, especially because you're calling snake.move from here. So snake.move is probably the main function, and we're passing in that direction, and it's giving us back a collision, which we're then going to check over here. So collision, non-apple self-wall. Cool. So it even tells us what kind of collision occurs, right? So the move function over here. Oh my goodness, this just looks like a mess. Like, look at this. This is like wall of code. Oh, okay. I feel like I'm gonna have to rewrite this function in order to actually see it properly. So this already makes it a bit better. Also, this like, what is it, like 2 spaces for a tab? I really am not a fan of this. This as well being on one line is a little bit ridiculous. I always basically put extra line breaks, I guess, after this. So instead of having this, it's like, okay, that's like an early out, I guess, in this case. Let's have that separated here. Again, with the noise you have with this. Oh, look, this one gets its own line for some reason. Sure. Then we have this get direction vector, another little if statement that assigns some stuff. And the rest of it, apart from there's so much this going on, man. But apart from that, separate out this collision that you're checking here so it's nice and clean. And there you go. Right. So I think this is much more readable, at a first glance. I'm definitely feeling a little bit better about just like the wall of colored text I was seeing earlier. Okay, so we're moving this particular new direction, and then Apple position is here as well. So Apple position. Okay, cool. So this is interesting, right? So I guess because of the simplicity of this game as well, what I'm realizing here as well is we don't exactly have like a scene or a game world that contains all the objects, right? So one thing that you would commonly see is obviously this concept of like a scene or a game world, or, whatever you want to call it. And then we have like, we've got the snake over here and we've got the Apple object. And these are both stored basically in some kind of data structure within scene. And so when you have to communicate between all of these, when you create one of these entities, they get instantiated with the concept of, okay, I'm in scene, right? So they kind of have access to the scene. They need to. That's the world that they reside in. And so if they need communication like between themselves, right, like this, then how do they can't. So they have to go back to scene, and they have to be like, hey, I'm looking for an apple. Can you tell me, if you've got an apple? So this is kind of like the, find object by tag or find entity by tag function in Hazel that will, look up something by its name, potentially in the scene. So in more simple games and more simple cases like this, you obviously don't really need to go through the effort of setting all of this up, because you could instead just be like, yeah, well, these are the only 2 things in existence, right? So how about we just, where necessary, even reducing it to this, we actually just pass in this object basically to be like, hey, Snake, you need to do something that involves Apple. This is Apple. And this is actually going one step further by being like, you know what? You don't actually need to know anything about the Apple apart from where it is. So here is just its position. So that's just, I think, an interesting note of, I guess, reducing complexity and making this a little bit more simple. So if the new direction is none, then sure, we just return. Otherwise, so has direction is interesting. So yeah, basically, so this is interesting because so has direction, I guess, is the current direction. So if it doesn't have a direction, because new direction is where you're trying to move now, if you're switching direction, and then has direction is where we are currently. And so if that's also none, then apparently we're not allowed to move left. Interesting. I guess it's like left is considered backwards or something, and we're not allowed to move that way. We can move anywhere but left. So is that true? Does that mean that if I just run this? Oh, because oh right, okay. So this is the head. I didn't realize. I thought for some reason I thought we started as just one thing, right? So that's another thing where with that function that was checking to make sure the apple wasn't on the snake, it would have to make sure that it's none of these three spaces. For some reason, I thought that the snake just gets like created as just one block over here instead of three. So yeah, so left would obviously move back into its own body, which is why they've disabled that. So that makes more sense. Okay, so then we get direction vector from new direction. Ah, right, because this is an enum. Okay. Yeah, I mean, I guess that kind of makes sense. Oh, look at this. I was expecting like just like a switch statement. Okay, so I don't know, man. I think this is maybe a little bit over-engineered. What I was kind of expecting and how I'd probably write this function without creating an entire map data structure for this is just have like a switch statement, you know, for direction that basically is just like, hey, you know, is the direction down, for example? And then if so, just return like a vector 2, you know, 0, -1 or whatever. That's actually up, 0, 1. And just have like up and left and right. And I don't know. I think that's just like, I'm expecting this to compile to much faster code because it's just like a little jump instruction versus having an entire unordered map that, by the way, is stored kind of like in static memory as well. It's not in this function, right? Because obviously it persists forever. Outside of this function. So like it's not in stack space is what I'm talking about. So I don't know. I think this is a little bit too much. In this case as well, obviously, like, you know, even with this code that I've written here, you could still do all of this, but you would just rewrite this to basically use the head direction instead of direction if that was the case. So basically what we could do is we could just set this direction that we're trying to check to head direction like that, and then pass it in this way. And then I guess you could make that not a const, right? So that's basically how I would write that function, I think. All right, moving on, vector2 add. Right, so this is Ray Math. Yes, of course, I forgot. We're using, there's like a C library for this, which is great. That was sarcastic. But anyway, Ray Math is like fine, but I don't know. I'm just used to like C++ operator overloading and like GLM and stuff, which I think looks a bit nicer. Okay, so we put into the body, we place back, std move new head position. It's really necessary to move this. It's like 8 bytes. Anyway, so we place that into there. I actually don't know. Like, I feel like, I don't know. Would a move even be like, I don't think a move would be any faster. If anything, I feel like a move would be slower in this case. Like, I don't know, actually, if like vector 2, does that have a move constructor? Like, I have a feeling this does absolutely nothing and just gets compiled out to not that. And this is obviously totally fine to do. So I'd probably do this. Unless you're trying to impress someone, maybe. I don't know. Okay, so then we have like detect collision, obviously, which is just gonna, oh my goodness, this wall of text. This is the worst thing about this entire code base, by the way, is just this like densely packed code. Look at this. Isn't this just easier for everyone to read? I don't know, people watching this video, is this easier for you to read or is this easier for you to read? Because I don't think it's this. And if it is, let me know. I'm going to talk to you. Like, have you on the podcast or something as punishment and try and understand why on earth you think like that. Okay, anyway, I'm going to accelerate a little bit here because we're getting a little bit time. We're taking up too much time with this code. Remove tail just pops the front of the body, sure. Okay, drawing, I guess. So how do we draw this stuff? So body part roundness. Okay, cool. You know, I kind of like, okay, these just do not need to be static. Like they're just floats and ints. Just keep them as const inside this function. It's going to be fine. Like having them static, I feel like I might do more investigation on this because this admittedly is one of those things that I haven't actually verified myself. But this is just going to, I feel like it's, if anything, it's going to slow down your code by just having the static because it's just making it less like local, I guess, or less like, because these might as well just be defines or something. You might as well just use 0.5 in here and you're great, right? Like they don't need to be, you know, statically stored in some kind of memory because but it's a static const expert on the other hand. So I feel like there's something special that must happen with that because obviously if it wasn't, then it's, you know, you could change it, which would mean that clearly that would have to be a variable some elsewhere in memory because it has to save your changes that you might make to it in here. Unless the compiler can look at your code and be like, well, you're actually not changing this, so let me just add that const for you. But a static const expr is interesting locally into a function, and I haven't seen that before. I don't think. And I've definitely haven't gone through like the assembly code and everything else and seen what it generates. So that's an interesting exercise. But otherwise we have this for loop. Wow. Here's something I haven't seen before either. So this is like a for each loop, it looks like, but you're also initializing a variable here. So this is kind of interesting. Like, I don't really understand why you would do that. I guess because you kind of want to use it here, and I guess you didn't want to write it like that. But I've never seen that before with an actual for each loop being the second statement of this. I didn't even know this was legal C or legal C++. So this is, yeah, cool, man. All right, then we have the snake body part with this stuff. Sure, we're setting all of this up. That's fine. Setting up a color based on this. Okay, right. So if the index is 0, it's the head. So we want to use, I guess, the head, although it says tail color. Otherwise, if index plus 1 equals body size, then we use head color. Oh, okay. So the head's actually the last thing in there because we're iterating from 0. So the head's the last thing in there. And the first thing in there, I guess, is like the tail. So it's like kind of like the first thing's always going to be the tail, apparently. Anyway, I don't think this is too important. And then we have our little, little flex here, our little std move. And this time I guess we got a rectangle, which is slightly more data, but still. Yeah, we're just telling Raylib to draw this at a particular coordinate, which obviously is here. And, we're storing coordinates, which is of course good, and then just multiplying them out by the cell size. Are we centering them as well within the cell? Because that's another thing I didn't really see here. So unless draw rectangle rounded draws it from the middle, because see, here's the thing. So when we have a grid like this, obviously, we want to draw like a rectangle, for example, but at the moment, the way it's set up, we're just doing x times cell size, which is going to give us like this coordinate over here, which is great if Raylib will draw that rectangle from this point. Obviously, that's perfect. We don't need to do anything. But otherwise, if Raylib draws rectangles from the middle, which is common, then obviously you need to offset that by like half of the actual width and height of the rectangle, which isn't happening over here. So I'm just wondering, like, if everything's misaligned, or probably more likely Raylib just draws from like the left or something. What else do we have here? So Apple is pretty simple. Oh yeah, the thing that I wanted to take a look at, remember, was, okay, I also don't like that nothing that you've included is actually in this project file. So you need to make sure your header files are actually like this stuff is actually in the project. So CMake's like actually including them as part of the project. They of course don't need to be compiled or anything, but they still should be navigatable and accessible through here, which would be good. But anyway, because see, now I can't find it. So I'm actually literally going to have to go to this directory on my computer just so that I can find what I'm looking for. Right? So you just give me all of these. Okay, so snake, HPP. So yeah, all this stuff is a drawable thing. And I'm just wondering why. So all this means is that it has a draw function. That's it. We're just being like, okay, snake has a draw function. So this draw function, I guess, gets called, if we go back to game, it gets called by game draw. So game draw does begin drawing, clears the background, then just calls apple and snake draw anyway. And in fact, apple and snake draw, they're stored, it's fine. I guess it's fine to store them like this. Some people would be a little bit, hesitant to not store them as pointers, just because that could lead to like object slicing, where you lose half the data if you cast back and forth between that not being a pointer and like the V table and stuff gets messed up. Anyway, a little bit annoying. But since you're clearly not using these at all as drawables, I guess you're just only adding drawable. Okay, I think I see what's happening here in a way. I think you're just trying to use this as an interface because you want, like, obviously this is a pure virtual, meaning you're basically mandating it to get implemented in all of the subclasses of drawables. So you're just being like, okay, I'm creating an object. I specifically want it to be drawable. So please make me implement this draw function. That obviously does also mean that you could just have a data structure of drawables, and the only thing that system that processes it would need to know is the fact that it's got a draw function, which it knows because it's a drawable, and that's it. So it can actually simplify code, obviously, by doing this. But I don't know. In this case, I think because you're storing game and apple as like, discretely as like separate objects of their exact type, I just feel like, we don't need a V table. We don't need indirection. We don't need anything like that. It just adds complexity to the, I guess, resulting binary for no reason, as well as the code, right? So I would just remove this and then, just live like this. I think that's totally fine, especially if you literally have two objects and you're also not using drawable anywhere, right? Like if we just do a search, yeah, so there's actually 0 results here. This is another really good reason why you need to make sure that your header files are actually included in your project, because you can see that I'm searching for drawable, it's finding 0 results, but we're looking at a file that clearly has drawable. That's because it's a header file and these header files are not actually included in here. Right, so it makes this much harder to deal with. And in fact, I probably have to actually look at like the current directory, or just go back to like here, you know, and specifically be like, okay, I want to look at this directory now to actually find what I'm looking for. And this also gives me a bunch of Raylib stuff, right? So you can see that they're only included in these header files and we're not actually using it. We've just marked everything as drawable and that's it. So I probably would avoid that. Cool. Well, that's pretty much all there is to this project. Let me know what you guys thought of it. I thought it was, yeah, I think this is a really good example of like a simple snake game implemented in C++ using Raylib. Nothing really too bad going on here. Definitely some unnecessary complications. And I think that the code could be better organized, like in terms of, you know, this stuff, like the actual formatting, but then also like perhaps separating out some game related functionality and application related functionality as well. If you guys want me to take a look at your code, then send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you guys for watching. I'll see you next time. Goodbye.